The information about fixture whips not exceeding 6 feet in length is found not in the National Electrical Code, but in NFPA 70E, the standard for electrical safety in the workplace. Specifically, Section 130.7C15 of NFPA 70E states this requirement. This standard focuses on safety practices and procedures to protect workers from electrical hazard. NFPA 70E addresses various aspects of electrical safety, including safe work practices, electrical safety-related work requirements, and safety-related maintenance requirements. The 6-foot limitation on fixture whips is intended to minimize potential hazards associated with longer, unsupported conductors in the workplace. Here's why this limitation is important. Firstly, it reduces the risk of physical damage. Longer fixture widths are more susceptible to being snagged, pinched, or otherwise damaged, which could compromise the insulation and create electrical hazards. Secondly, it minimizes stress on connections. The weight of a long, unsupported fixture whip can place undue stress on the connections at both the fixture and the junction box, potentially leading to loose connections and arcing faults. Thirdly, it limits the potential for voltage drop. While voltage drop is typically more of a concern in longer circuit runs, limiting the length of fixture widths helps to ensure that the voltage at the fixture remains within acceptable limits. Fourthly, it improves overall safety. Shorter fixture widths are easier to manage and control, reducing the likelihood of accidental contact with energized conductors. Now let's elaborate on the key aspects of NFPA 70E and its relevance to electrical safety. NFPA 70E is not a design specification like the NEC, but rather a standard that outlines the requirements for electrical safety in the workplace. It is intended to provide practical guidance for employees and employees to identify, evaluate, and control electrical hazards. Understanding the scope and application of NFPA 70E is crucial for anyone working with or around electrical equipment. The standard covers a wide range of topics, including hazard identification, risk assessment, personal protective equipment, safe work practices, and training requirements. Employers are responsible for developing and implementing an electrical safety program that complies with NFPA 70E. This program should include procedures for identifying and evaluating electrical hazards, selecting appropriate personal protective equipment, and training employees on safe work practices. Employees are responsible for following the procedures outlined in the electrical safety program and for using the personal protective equipment provided by their employer. They should also be aware of the potential electrical hazards in their work area and take steps to minimize the risk of injury. One of the key elements of NFPA 70E is the hierarchy of risk control methods. This hierarchy prioritizes the most effective methods for controlling electrical hazards, starting with elimination and substitution, followed by engineering controls, administrative controls, and personal protective equipment. Elimination and substitution involve removing the hazard altogether or replacing it with a less hazardous alternative. For example, de-energizing equipment before working on it is the most effective way to eliminate the risk of electric shock. Engineering controls involve modifying the workplace to reduce the risk of electrical hazards. Examples of engineering controls include installing ground fault circuit interrupters, providing guarding around energized equipment, and using insulated tools. Administrative controls involve implementing procedures and policies to reduce the risk of electrical hazards. Examples of administrative controls include developing lockout-tagout procedures, providing electrical safety training, and conducting regular safety audits. Personal protective equipment is the last line of defense against electrical hazards. Examples of personal protective equipment include insulated gloves, safety glasses, and flame-resistant clothing. It is important to select personal protective equipment that is appropriate for the specific electrical hazard and to use it correctly. NFPA 70E also includes detailed requirements for specific electrical tasks such as working on energized equipment, performing lockout-tagout, and inspecting electrical equipment. These requirements are designed to ensure that employees are protected from electrical hazards when performing these tasks. Let's consider some specific examples of how NFPA 70E applies in a workplace. Imagine an electrician who is tasked with troubleshooting a malfunctioning motor control center. Before beginning work, the electrician should follow the procedures outlined in NFPA 70E to identify and evaluate the potential electrical hazards. This may involve performing a hazard risk assessment to determine the arc flash and shock hazards associated with the equipment. Based on the hazard risk assessment, the electrician should select appropriate personal protective equipment, such as arc-rated clothing, insulated gloves, and a face shield. The electrician should also follow lockout-tagout procedures to energize the equipment before beginning work. If it is not possible to energize the equipment, the electrician must follow specific safe work practices for working on energized equipment. This may involve maintaining a safe working distance from energized parts, using insulated tools, and wearing appropriate personal protective equipment. Another example is a maintenance worker who is responsible for inspecting electrical equipment. The maintenance worker should be trained to identify potential electrical hazards, such as damaged insulation, loose connections, and exposed conductors. The maintenance worker should also be familiar with the requirements of NFPA 70E for inspecting electrical equipment. If the maintenance worker identifies any electrical hazards, they should report them to their supervisor so that they can be corrected. It is important to note that NFPA 70E is a dynamic standard that is updated regularly to reflect changes in technology and best practices. Employers and employees should stay up to date on the latest requirements of NFPA 70E to ensure that they are following the most current safety practices. In addition to the 6-foot limitation on fixture whips, NFPA 70E addresses a wide range of other electrical safety topics, including arc flash hazard analysis, personal protective equipment, and safe work practices for working on or near exposed energized parts. Arc flash is a dangerous phenomenon that can occur when a short circuit or other electrical fault creates an explosive release of energy. Arc flashes can cause severe burns, blindness, and even death. NFPA 70E requires employers to perform an arc flash hazard analysis to determine the potential arc flash hazards in their workplace. The arc flash hazard analysis should identify the potential arc flash boundary and the incident energy at various locations. Based on the arc flash hazard analysis, employers should select appropriate personal protective equipment for employees who may be exposed to arc flash hazards. Personal protective equipment for arc flash protection includes arc-rated clothing, face shields, and gloves. NFPA 70E also includes detailed requirements for safe work practices for working on or near exposed energized parts. These requirements are designed to minimize the risk of electric shock and arc flash. Safe work practices include energizing equipment before working on it, maintaining a safe working distance from energized parts, using insulated tools, and wearing appropriate personal protective equipment. In summary, the 6-foot limitation on fixture widths is just one small part of the comprehensive requirements of NFPA 70E. This standard is essential for ensuring electrical safety in the workplace and protecting workers from electrical hazards. Understanding and complying with NFPA 70E is crucial for employers and employees alike. Remember that electrical safety is everyone's responsibility. By following the requirements of NFPA 70E and practicing safe work habits, we can all help to prevent electrical accidents and injuries. To further elaborate on the practical implications, consider different types of electrical installations. In commercial buildings, fixture whips are commonly used to connect lighting fixtures to the branch circuit wiring. The 6-foot limitation applies to these installations, ensuring that the whips are not excessively long and prone to damage. In industrial facilities, fixture whips may be used to connect equipment such as motors, control panels, and other electrical devices. Again, the 6-foot limitation is in effect to enhance safety and prevent potential hazards. Even in residential settings, although NFPA 70 primarily focuses on workplace safety, understanding the principles behind the 6-foot limitation can inform safer practices. For example, when installing or replacing light fixtures, keeping the connecting wires as short as practically possible can contribute to a safer installation. The rationale behind this length restriction also ties into broader electrical safety principles, like minimizing the amount of exposed conductors and reducing the potential for accidental contact. Longer whips can increase the chance of someone inadvertently touching a live wire, especially in cramped or poorly lit spaces. Furthermore, maintaining shorter lengths can simplify troubleshooting and maintenance. When issues arise with lighting or equipment, shorter whips make it easier to trace the wiring and identify the source of the problem. Lengthy, tangled whips can complicate the diagnostic process and potentially increase the risk of electrical shock. Another important aspect to consider is the type of conductor used for fixture whips. Typically, fixture whips are made with flexible metal conduit, or FMC, which provides physical protection for the conductors. However, the type of conductor and its ampacity rating must be appropriate for the circuit it's serving. A NEC provides guidance on selecting the correct conductor size and type based on the load requirements and the installation environment. In addition to the 6-foot length limitation, there may be other local codes or regulations that apply to fixture whip installations. It's always essential to check with a local electrical inspector or building department to ensure compliance with all applicable requirements. These local rules could relate to the methods of support, grounding practices, or other installation details not explicitly covered in NFPA 70E or the NEC. The purpose of these requirements is to ensure a safe and reliable electrical system. Remember, while NFPA 70E focuses on worker safety and the NEC covers electrical installations, both are closely related and have the common goal of preventing electrical hazards and protecting people and property. Continuing on the topic of safety, let's explore arc flash in more depth. Arc flash events are dangerous and can cause severe injuries. An arc flash is a phenomenon where an electrical discharge travels through the air, creating intense heat and pressure. The heat can reach temperatures of up to 35,000 degrees Fahrenheit, which is hotter than the surface of the sun. The pressure wave from an arc flash can also cause significant damage, and the intense light can cause blindness. NFPA 70E provides detailed guidance on how to protect workers from arc flash hazards. One of the key requirements is to perform an arc flash hazard analysis. This analysis involves determining the potential arc flash boundary and the incident energy at various locations. The arc flash boundary is the distance from the potential arc flash source where a worker could be exposed to a hazardous arc flash. The incident energy is the amount of energy that a worker could be exposed to during an arc flash event. Based on the arc flash hazard analysis, employers must select appropriate personal protective equipment for workers who may be exposed to arc flash hazards. This equipment includes arc-rated clothing, face shields, gloves, and other protective gear. Arc-rated clothing is designed to protect workers from the intense heat of an arc flash. This clothing is made from special materials that are resistant to heat and flames. Face shields are designed to protect workers' faces and eyes from the intense light and heat of an arc flash. Gloves are designed to protect workers' hands from electric shock and burns. In addition to personal protective equipment, NFPA 70E also requires employers to implement safe work practices to minimize the risk of arc flash. These practices include energizing equipment before working on it, using insulated tools, and maintaining a safe working distance from energized parts. De-energizing equipment is the most effective way to prevent arc flash. When equipment is de-energized, there is no risk of an electrical arc. However, de-energizing equipment is not always possible. In some cases, it may be necessary to work on energized equipment to perform troubleshooting or maintenance. When working on energized equipment, it is important to use insulated tools. Insulated tools are designed to prevent electric shock. It is also important to maintain a safe working distance from energized parts. The safe working distance depends on the voltage of the equipment and the potential arc flash hazard. Finally, let's address some common misconceptions about electrical safety. Firstly, many people believe that only qualified electricians need to worry about electrical safety. However, electrical hazards can affect anyone who works with or around electrical equipment. It is important for all workers to be aware of the potential electrical hazards in their work area and to take steps to minimize their risk of injury. Secondly, some people think that personal protective equipment is all that is needed to protect against electrical hazards. While personal protective equipment is important, it is only the last line of defense. It is important to implement a comprehensive electrical safety program that includes hazard identification, risk assessment, safe work practices, and training. Thirdly, some people believe that they can identify electrical hazards simply by looking at them. However, many electrical hazards are not visible. It is important to use appropriate testing equipment to verify that the equipment is de-energized before working on it. In conclusion, electrical safety is a critical concern for all workers. By understanding the requirements of NFPA 70E and implementing safe work practices, we can all help to prevent electrical accidents and injuries. The 6-foot limitation on fixture whips is a small but important part of a comprehensive electrical safety program. Always consult the latest edition of NFPA 70E and the NEC for the most up-to-date information and requirements. This ensures that all electrical work is performed safely and in compliance with applicable codes and standards.